All right, let's do this. I think we are live now. Hello, everybody. Happy Friday. Yes, happy Friday. Welcome. It's Friday. Hello, everybody. Welcome to my live stream. I'm your host. My name is Aaron Patterson. I'm your host, as always, Aaron Patterson, also known as Tender Love. I hope you're having a good Friday today. I am having a good Friday so far, though I've only been at work for like an hour. So, I mean, so far it's all right. Today on. Oh, I have a background here, which is a fish. It's not because I use fish shell. It's because Ebby and I went to the Ballard Locks here in Seattle. If you get a chance, you should definitely check out Ballard Locks. They have like a fish ladder, so you can see the salmon swimming upstream. It's really cool. So this is a photo from the one of the salmon from the fish ladder, which is a lot of fun. Today on the live stream, we're going to be speeding up array.pack. So I'm gonna talk about that, like how we're gonna speed that up. We're not gonna do anything super fancy. Like we're gonna get rid of an array allocation from it. Hopefully, I did do homework on this, so hopefully it'll go pretty well. Anyway, I don't have a guest today, so I am depending on you, dear viewer, to interact with me in the chat today. So I'm gonna go through some slides about how the VM works, and then we'll get into speeding up array.pack. If you have any questions, of course, like drop them into the chat. Also, like if you have any ideas or ideas for future live streams, put them in the comments too. Or if you have any questions about, if you're a future viewer and you have any questions about this, put it into the comments and I'll answer them as best I can. So let's get started. Where is the keynote? There we go. Keynote. Show me keynote. Okay, so yes, today we're going to do speeding up array.pack. Oh crap. Happy Friday, everybody. I was gonna talk about TenderJIT this week. Oops. No, I don't want to put it in there. Yep. I was going to talk about TenderJIT this week, or this month, but I decided like I wanted to do something that would be like a little bit more useful. I love hacking on TenderJIT. It's a really fun project. And usually I only get a chance to do it on the live streams, but I wanted to do something that would be a little bit more useful, I guess. Not that TenderJIT isn't useful, just like maybe something that we can actually ship and everybody can use. Somebody, like, the origin of this is that somebody filed an issue on bugs.rubylang saying like, hey, I'd really like it if there was a new method where we could do array, like pack stuff, use the pack method, but not allocate arrays. And we can actually like get rid of the array allocation, and that's what we're gonna do today. So today we're gonna try hacking on array.pack, and then see if we can get rid of the array, or get rid of the array allocation. So as an example, like what is array.pack? It's a really simple method. All it does is it takes we take an array of numbers and then integers, for example, and then we provide it. So we have an array of integers here. We call pack, and we provide pack with a format string. And all the format string does is tell the method like how to convert this array of integers into a binary string. So for example, here we have like 3 C's in a row. Our format string is 3 C's, and we're saying like, hey, I'd like you to take these 3 integers and turn them into 3 bytes. So we're gonna turn each integer into its own like byte. So when we call pack, we'll get back binary data. And of course, like there's an opposite method as well. There's an unpack method. So that string that we got, which is 3 bytes of data, we can say like, hey, I'd really like you to unpack this, convert it back into an array of integers. And that array of integers is formatted with 3 C's. So we can say like, we can pack it and then unpack it using the same format strings. So this format string is like a miniature language. Like it's kind of a miniature programming language. And to be honest, like I have to look it up every single time I use this. Yes, Sam says recurring theme of get rid of array allocations. Yes, yes, that is what we are here to do. Anyway, this is the pack. That pack format string is it's a miniature language, and honestly, I can't remember it. I always have to look it up. And if you're like me, like this is the documentation for it, so highly recommend go check out this documentation. And then you can understand all the different formats that you can pass in. I never ever remember this. I have to look it up every time. Uh, so let's take a look at this. Yes, array pack is absolutely for when you want to feel C-like in Ruby. Actually, I think like the best I don't know, really good use case for array pack and unpack is when you're doing like binary protocols. So one case I could think of is like if we wanted to write a pure Ruby version of protobuf, for example. Like you're getting binary data over the network, and you want to convert that. Thank you, thank you for the engagement. We're trading engagement for content. Thank you. So anyway, you get binary data over the socket, over the network, and you want to convert that binary data into an actual data structure. You'd use unpack for that. And likewise, if you wanted to take your data structure and convert it back into a binary format, send it back across the wire, you'd use pack for that. So anyway, you can find all the documentation here. Here's an example of what we're going to be eliminating today. So today we have like this array here where we're allocating an array, and we're going to eliminate this array allocation. So like you can tell just by looking at this code, like we don't actually need this array. We're creating an array, we call pack, and the return value of pack is a string. So we create the array, and then we like throw it away immediately. So there's like no reason for this array to exist. We don't really need to allocate it. And actually, there's an easier example of this, which is array hash. And John Hawthorne and I hacked on this a few months ago. So if you go through my YouTube archives, you can look at this. We implemented array hash a few months ago, and I want to revisit it because it's a more simple example of. Oh, hello, John. It's a more simple example of what we're going to be doing today. So like, here's a hash example. This is just like our pack example, but it doesn't have a parameter. So the main difference between this hash example and our pack example, there's no parameter involved. So let's walk through how the virtual machine works with the hash example. We'll look at how the VM works, and then we'll try to translate that into what we'll do with pack. So let's see. Here's our like instructions, our VM instructions for that code on the previous slide. First thing we do is we push the integer 1 onto the stack. Then we'll push integer 2 onto the stack. We'll get local on C. Let's say that the C local variable has the value 3 in it. We'll push 3 onto the stack. Then we'll call new array. The new array instruction, it pops 3 values off of the stack, and you can tell that because it's got new array 3. So you see let's see if I can see over here. Yes. You can see new array 3, like we know that it has 3 values, so it pops 3 off the stack, it allocates an array, it pushes that array onto the stack, and then finally we call send with hash. That sends the hash method, it calculates the hash, pops the array off, pushes the hash value back onto the stack. So the new array instruction allocates that new array, and that's the thing that we want to get rid of today. So let's take a look at one other thing. The new array instruction allocates a Ruby object. It knows the length of the array that it wants to allocate from that instruction. We saw it when we said new array 3. It allocates a buffer. So the first thing it does is it allocates an array object, and the array object has the length 3 inside of it. Then it allocates a buffer for the array contents. And basically all it does is it takes the values from the VM stack and copies them into that array buffer. Now, it's a little bit more complicated than this. I'd try to simplify it a little bit because there's different types of array layouts, but this is the basic operations. So copies all that stuff out. Now, when we calculate the hash of the array, like when we're calling array.hash, in order to calculate the hash of the array, all we do is we just iterate over each value in the array buffer, calculating the hash. Now we have the array. In order to iterate over the array, we have to know the array's length, which we have inside of the Ruby object, and we also have to have that buffer of values to iterate over. So we have both of those two underlying pieces. Now, if we go back to the VM instructions and we take a look at the VM instructions and we pause right here before actually allocating the array, we can see like, oh, we have the length here embedded in the array, or embedded in the VM instructions. So we have that value 3, we know the length. And we also have the buffer for the array. The buffer for the array is actually on the VM stack. So we have those two pieces of the puzzle. We know the length and we have the buffer, so we can actually iterate over all of those even though we don't have a Ruby object. So what we do is we introduce an optimization pass that detects the pattern, this particular pattern where we're pushing some number of values onto the stack, we're calling new array, and then we're immediately calling hash. So what we do is we say like, well, instead of calling new array and then hash, why don't we emit a specialized instruction, and that specialized instruction calculates the hash. And that's exactly what we did a few months ago. We introduced this new array send instruction where we say like, hey, I'd like you to call the hash method and I need you to operate on the top 3 values of the stack. So this new array send, it just calculates that hash without actually allocating the Ruby object. So it'll pop those 3 values off, calculate the hash, push the 3 values back on. And in fact, if you run this code today, like you can see the optimized code get generated right here. It'll say new array send. I put it backwards in the previous slide because I made a mistake. But you'll also notice like we've implemented it for min and for max. Sam is asking, is this used for min and max too? Yes, min and max get it. So we have hash, min, max, maybe, I think that's it. We'll take a look when we dive into the code. But one thing about hash, min, and max is that they don't have any parameters, which is pretty nice. Unfortunately, pack has 1 parameter, so we're gonna have to figure out how to deal with that. So hopefully we can do that today. My current plan is, what we'll do is we'll say like, all right, on the left here, the left side instructions, those are the original instructions where we're putting objects, we're creating a new array, and then we're calling pack. What I want to do for the optimized instructions is we'll say like, hey, we're going to do new array send pack, and instead of passing 3, we're going to pass 4. So 4 is the number of objects that 4 is the number of values we're going to be popping off the stack, and we'll know that since we're operating with pack, we know that the topmost value is the pack string, and then n-1 values are the array size. So we'll know here like, hey, the array size is actually n-1, and the pack value is the top value. So okay, let's do it now. Let us hack on this. All right, where is me and desktop? All right, cool. We're gonna hack on this. If you have any questions, please put it into the chat. I'm happy to answer anything. Also, I might need help in here, so if you see me making mistakes, please say so. All right, let's start with a test program, I guess. Let's do just like, I don't know, a = 1, and then we'll do like, Pablo is asking, do you need to add new specialized instructions for each optimized pattern? Is it possible to do the same with primitives? Yeah, right now we have to add specialized instructions for each pattern. Actually, one of the things that we did, like a few, Pointless One is asking, wouldn't it break for a patched pack method? Absolutely, yes. We're going to have to take into account monkey patches, which we will do. Sam is asking, any way for it to work with variable args? Maybe. I don't know. Yes, I need static type checkers in the chat, please. All right. So we're gonna get it working. We'll get it working without monkey patch supporting first, and then we'll add support for like dealing with monkey patches later. Another thing is like, I really want to get this introduced because in the future, it'd be really cool if we could have YJIT detect that we're doing pack calls and then generate machine code based on the pack, like the pack format string. So let's do this. All right. Oh, right. The other thing I was going to say is we used to have, so one of the refactoring or one of the things we did, or John and I did, to refactor the previous, like when we did the hash implementation, we actually had a specialized instruction for each type, like min, max. Boy, I feel like there was something else. There was a special one for min and max, and we would have had to like create a third one for hash. But instead, what we did is say, okay, we're gonna combine all of these into one instruction, which is opt array send or whatever, and then we give that a parameter, which is the particular method that we're calling. So we'll do like, let's do this. All right. So we got 1, 2, and then a.pack, and we'll just do ccc. And if we run this, boy, I feel like I should put the code. I'm gonna try to put the code here so we can see the code and that. Okay, there we go. Boy, got Safari up here. Yeah, we don't need that. All right. Let's see. Dump ruby dash dump. Well, let's do mini ruby dash dump insns test.rb. There we go. So we see we've got like put object, set local, put object, new array, op send without block. So we want to optimize this pattern. So the first thing we're going to do is we're going to have to look in compile.c and find the people optimization passes that do this, and then add some code there. So compile.c has all of our code for, oh boy, I'm gonna make this smaller, and I should see myself here. All right, sorry, I'm gonna make the font a little bit smaller. Hopefully you can still see it. Let's see. Oh, that's bigger. We don't want that. There we go. Pull this down. All right. So compile.c has all the code for translating the AST into a linked list, which gets turned into bytecode later on. But it also contains all the peephole optimizations, like optimization passes that we perform on the linked list. And one of them is here. This is our case ISEC specialized instruction. So this is the particular one that does our new array, like our new array send stuff. So all we're doing when we're doing these peephole optimizations, all they do is they like look at the code, look for a particular pattern in the instructions, and then replace that pattern with something that's more optimized. So in this case, we're saying like, hey, do we have a new array instruction? And let's see, what else? Is it calling, if we have a new array instruction, is the argc, like, do we have, let's see if I can point this out here. Right here, we're saying, is the argc 0? So are there 0 parameters? So the pattern we're looking for is ID max, min, and hash with 0 parameters. And if we find that, then what we're going to do is manipulate the linked list and insert a new instruction. Where is it? Right here. So here's our optimized, our new array send optimization. So I think the first thing we're going to do is what? So right now it's insisting that argc has to be 0. So the number of argc is the number of parameters that we're passing to the method. It's insisting that it has to be 0. We're going to do 1 because we want to work with pack. So let's do like, I don't know, less than or equal to 1 maybe. And then I'm going to just put a printf in here to see if we actually get into this when we're compiling this stuff. Chip says so many parentheses, delete them. Yeah, like, so I do Seattle style programming in Ruby, but I feel like in C, just add as many parentheses as possible because I can never remember precedence. So I'm like, just throw more parentheses in. My my C is a lot more like my Lisp, I think. All right, let's see. Hello. Let's just print out hello. See if we actually get in here. I'm not sure. So one other thing is we have to check like this particular check right here. This is like make sure that we have a simple method call. So a simple method call is something that doesn't take a block, or I also believe it's something that's like no splats, no things like that. So it has to be like a very simple method call. I think one parameter counts as that. So let's check if we actually get in here. That's all I want to do right now. Let's do this. Make. Oh, I should have built this in advance. I'm probably going to reconfigure and we'll just have to... Oh, good. No. Okay, great. I was afraid it would have to reconfigure and then I'm just going to have to sit here awkwardly on the stream like, oh, okay, hold on. All right, let's try this. Mini Ruby. Let's just run the program. Test. Oh, man, we got in there a bunch of times. Okay. I don't know why. Let's see. Let's do less than or equal to 1 and boy. These ones, so like we don't want to go into the switch statement. Like we definitely don't want to deal with ID max min and hash if argc is 1. Like that's a thing we don't want to do. I'm not going to deal with that right now. Let's not care. Let's just add pack in for now. So we need ID pack. Actually, we can... No, let's just do it. Just do like, what? Break. If... Let's just say like, if argc is not 1, we'll just break out of here. If it's not equal to 0, then I don't know. We don't want to do this. Just Yep, this seems fine. All right. Let's do case ID hash or not hash. We're doing pack. Nested switches. I don't know. I don't think we want to do nested switches. Not this. That's a more advanced. I'm not that advanced in C. All right, let's do ID pack. Now, ID pack, these IDs are defined in a very annoying place. There's this file that defines them, like it defines a whole bunch of symbols. So this ID, like ID max, ID min, ID hash, these are actually Ruby symbols, or well, they're IDs. They're not really symbols. They're integers which represent the symbol max, min, and hash. And they get defined in a weird place, which is, I can never remember where. So what we're going to do, I actually asked John yesterday while I was prepping for this, where the heck are these things defined? And he told me, and I forgot. And what we're going to do instead is we're going to look at git history, git blame, and then see if we can find it. Let's see. Let's do P on that guy. All right. Oh, yeah, because we did this. We had to add hash. So, like, hash is a new one, right? We did hash. So, it's like, where did we do that? We must have introduced it in this commit. Let's take a look at that. Git show. Nope. Git show this commit. And where did we put it? We put it in... Boy, this font is really big. I'm going to make the font a little bit smaller. If it's too small, like, somebody say something. There it is. So there's this like weird file, defs, id defs id.def. So we're going to edit that. This thing defines symbols in advance. So it basically pre-allocates these symbols. Actually, I'll show you what happens if we don't do this. It should give us a compile error. It's going to be like, I don't know what ID pack is. Yeah, there we go. I don't know what ID pack is. So we got to define ID pack. I'm going to do that in here. I don't know if these have an order. They do not seem to be in alphabetical order. We'll just add pack. There we go. All right. So ID.pack should be defined now, I think. Let's just see if it compiles. It did compile. Let's add like a, let's put our printf here. But we're just gonna break, so we shouldn't get any optimized instructions out of this. Let's do mini Ruby test. Okay, it didn't work. Why? Let's see. This is the part, okay, this is the part where I'm gonna really need some audience participation. I have no idea why this didn't work. I would have expected it to work. Let's see. Why? It is a good rule to have a font size as large as you open your mouth, and you can pretend you're speaking the. Woo, yes. Let's see. Okay, why are we not getting in here? How can we debug this? We're looking for blah 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 send. We're looking for a send on something. Let's take a look at the instructions that get generated from test. The original instructions, and we're gonna do, let's see, I'm gonna pull this up here, ruby dash dump. Actually, let's do dash help. There's a way to do, so like insns. Oh, let's do / mini ruby dash help. Yeah, we want this, is better. Wait a minute. Yeah, okay. So when you dump instructions, like you can do mini Ruby. Boy, let's make this. I just put this at the top here. So you can do like mini Ruby dash dump, and if you do insns, it'll give you the instructions, but they're optimized. So like you see this put obj into fix 1 like that, and set local water closet 0. I don't know what WC stands for, but I always say water closet in my head. These are optimized instructions. So like, if we want to see the instructions that are not optimized, you can provide a different value. You can say insns without opt, and now we can see like, oh, okay, here's our jam. Ah, here is the problem. Okay, so the pattern that we're looking for in here is like, we want min max new array, min max with an array. So we're saying like, hey, followed by a send. So we need like new array and then a send immediately after that. But we don't have that. We're doing new array, then we're doing a put string, then we're doing a send on pack. So this is a little bit more complicated. The pattern that we're originally looking for was new array and then send, but we have new array, put string, send. So this is a little bit harder. Let's see. Okay. So let's say, okay. Here's what we want to do. This is going to be I feel like these people optimizations are just total hacks, because really what it is, you're just looking for like these hard-coded patterns. Like, okay, let's take that hard-coded pattern and turn it into something else. So we're looking for a send. The next object is a send. Yep, that is true. So this is saying like next, so right after put array is a send, and then we need to be like right after, actually we don't want that. Right after the put array, we want put string. That's what we want. So let's look for put string, and then right after the put string, we want to send to pack with argc1. Actually, let's do that. We're gonna do oh boy, I guess let's just like, let's be super hacky, because we're just having fun here. Let's do like, what is that, next iobj? Let's do like next iobj. I don't know. So let's check if this one is send. So if the next iobj is send, then we're going to take a look at it. So we'll get the call info. Call info is information about the call site. So it's like how many parameters it has, what the name of the method is. And we need that call info on the next iobj. and then we're gonna check, okay, does it have exactly, oh boy, my 80 column thingy is not working out for us today. Does it have exactly one, can you see that? Yeah, does it have exactly one parameter? That's what we're looking for. Does it have exactly one parameter, and is that parameter pack? That's like that's our thing. Let's see, Y3 down. Let's take this. We're just gonna copy paste some code here because we're just hacking to get this work basically. Okay, so let's undo this. Let's do that because we're not gonna enter this pattern. This pattern doesn't work for pack, unfortunately. So put that back. Okay. Let's give this a whirl. So we're looking for a put string, then we're looking for a send. Right after put string is a send. So it's like so many if statements. It's like we're looking for new array followed by put string followed by send with pack. Mateus Richard asks, I'm not super familiar with pack. Is there any specific reason to optimize it? Yeah, the main reason to optimize it is because a really, really common pattern is that people will just do this. They'll do this array.pack, and they don't really care about the array allocation at all. It doesn't matter. They just want the binary string that comes out of pack. So we just want to get rid of that array allocation. The other reason is if we emit an optimized instruction for that, it's much easier for YJIT to detect that, hey, we've got a pack call, and I think that in the future we'll be able to generate custom machine code for it. Okay, so we're looking for this. Let's see if we can actually get our printf here. Let's try that. Hey, nice. We got our printf. Great. Okay. So we didn't optimize it. We haven't emitted an optimized instruction. We've really just like detected the pattern in the original bytecode or in the original instructions. Excuse me, I keep messing those up. We're currently working with a linked list. That linked list will be converted to bytecode. So let's do this. Oh yeah, let's get rid of this. We don't care about that. Now here, I feel like we can basically just copy paste this, which is what we're gonna do. Because we like to copy paste stuff. And we're gonna do new array send. We're gonna do, what is this? Compile data alloc, calloc2. I'm going to ignore this because I don't know what it's for. Num, where did num come from? Num is from the operands. I see, that's the original number of operands. Okay, and I think we want to add 1 to that. +1. Then we get our symbol out. Oh, boy, actually, I don't know about that. Let's do that. Well, let's see what this does. We should get an optimized instruction out of this. Whether or not it's correct, I am not sure. Yes, that's correct. We're just looking for a particular patterning and replacing those with, yes, that's exactly what we're doing. So let's see. I think this will output an optimized instruction, but I don't know if it's the right one. Like, it might mess up. It might be wrong. Let's check it. Okay. That is not what we wanted. All right. Let's see. Let's do this. LDV. Oh. Just as looks good to me. Yeah. All right. Let's run it. Why are we breaking? Bad. Exec bad access. Okay, so one thing that stands out to me as I'm looking at this is we have the address 8, which I believe is q nil. So that's kind of interesting here. We got a nil that we're working with, seems like. So let's go BT, I don't know, 5. Okay. Oh, interesting. Boy. Yeah. Let's try to get back to our code. Okay. Okay. SP Inc. opt array new send. Oh, interesting. Interesting. You know what's going on here? I think we're not removing enough instructions. So like we have that extra string. I think we need to remove that as well. Like there it is. Yeah. It's this guy. So remember, we're manipulating a linked list. The original optimization is saying like, hey, I want you to remove that. I want you to remove the ni object, which was in this case the call to send. So we're saying, hey, I want you to remove the call to send, and I need you to just remove it. I remember what this code is doing. This is a super hacks. This is very, very much hacky. So like this I object is the current linked list object, which represents the call to, what is it? New array. So this is the new array instruction. And what's happening in the original optimization is that we're taking the new array instruction and we're mutating the new array instruction. We're actually overwriting it, which is like, I don't know, not cool, I guess. Like usually I don't like to mutate stuff, but that's exactly what's happening here. We're mutating the original instruction to be a new array send, and then we're removing the send instruction. So with that in mind, what do we need to do up here? We want to keep the put string instruction. We need that. So removing this one is wrong. We want to get rid of the send instruction. That's true. So let's get rid of that one. And I. So that one's going to go away. What else we got going on here? IOBJ is what? IOBJ is the new array instruction. Yeah, we want to overwrite the new array instruction. Let's try this again. I think it's not going to crash this time, but I think the instructions will be incorrect. So let's take a look. Boy, I should have practiced this a lot more before the live stream. Okay. Oh no, I was wrong. All right. What is going on here? Let's see. Run. Okay, still 8. That's interesting. PT 15. What we got going on here? Yeah, it's still a problem with the SP depth. So when we're compiling these, we try to calculate the size of the stack pointer, and we've got some maths wrong when we're calculating the stack pointer. Let's just, for now, let's do this. Let's also remove the put string. Just see what it looks like. Make sure we can get the... Thank you for saying this is more entertaining. I appreciate it. Feeling a lot of pressure here. So we're going to delete the put string instruction just to see if we can get the stack alignment correct. See if that's indeed the problem. Yeah, that is indeed the problem. Okay. Well, that's good. So like, just to kind of show what's going on here, we created a new opt to new array send, and we added pack to it, and we said that the stack it's going to manipulate are 3. We're going to pop 3 values off. We're going to call pack on that. And unfortunately, that's like wrong. We still need the string. Like we still need, we still need the pack formula. Dang it. Thank you, everybody. I got it to compile, but it's completely wrong. All right. Okay. So let's see. New array send, operand size is correct. Num, I think we want +1. It's supposed to be +1. Let's do +1. Oh, I know what the problem is. No, I don't know what the problem is at all. Oh, I do know what the problem is. So the issue is that, how do I describe this? We're pushing 3 values onto the stack. and then we're trying to create this. We're trying to do this method call. Generic Steel is asking, why is this supposed to be +1? Because we want to, the thing that we want to end up with, let me just write this out in code here. The instructions that we want to end up with are like, in this case, like, so just imagine this here. We're going to do like put object 1, put object 2, get local A, and then the original instructions are like, you know, new array 3, push string, I don't know, push, whatever it is, push CCC, and then send pack, like that. So what's going on here is when we go through the optimization pass, we're taking this new array 3 here, and we're actually converting it into opt new array send pack, 3, right? But what we want to end up with, like this pack method needs the parameter, and we have to have that parameter on the stack, and we haven't pushed the parameter on the stack yet. So this push CCC is too far down. We need to actually take this push CCC and put it right here. So part of our optimization pass is a little bit missing. We got to take this push and move it from here up to here. So let's figure out how we can do this. You know what I think we should do? So like right here, this iobj, it's like we're mutating, what are we mutating? We're mutating this new array instruction. I think what we should do instead is mutate the send instruction. So if we mutate the send instruction and then delete the new array instruction, I think that that'll get us the right, like the right stack offset as well as the correct optimized instruction. So let's give that a whirl. So instead of mutating iobj, let's mutate, is that going to be nn iobj, I guess. So we'll mutate nn iobj, then we'll delete, what are we going to delete? We want to delete, the, what do we want to delete? I already forgot. Please help me out here. These variable names are really not helping me out here. We want to delete iobj. We don't want new array, so that's going to go away. Let's get rid of that. Actually, I think that's the only thing we want to delete. Yeah. All right. Give this a whirl. Oh, God. K. K. All right. All right. What are we doing wrong? Let's see if it's still, let's pull it up in LLDB and see if it's still a stack size problem. Oops. Run. Yeah, sure looks like it. Calculate stack depth. Boy. Fix SP depth. What are we doing wrong? So we want to delete, let's just walk through this again and think about it. So we have new array 3, and we want to delete new array and convert pack into this new array send. That's what we want to do. Okay. What are we doing here? We're saying nn iobj is send. We're mutating nn iobj. Oh. How does the interpreter push CCC before the pack? It knows during the compilation process. So we have this CCC. Let's see. C. Ha 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 ha. C. Ha ha ha. Let's see. iobj link. We want to get rid of iobj. And we want to do niobj is good. Nn iobj is the thing right after put string, which is correct. That's what we want. We mutate that. Do that. What is operands? Let's print out operand. let's print out operands here. Printf error. I don't know what this num is. I assume num should be 4. Let's check it. Yeah. Generic steel. Can we just confirm the instructions we're working with before we transform them? Absolutely, yes. That is a great idea. Let's check. I want to check the stack, like this num thing here real quick. And then actually, oh, you know what? This operand size is probably wrong too. Operand size should just be 2, I think. But let's just look for a sec. Okay. Let's do make minus j mini Ruby. Okay, sure, that's fine. Actually, let's do an exit here. I don't want to look at a crash. Okay, run. Num 8, that seems, oh. Are these Ruby numbers? Oh, yes, I think they might be. Let's add 2. Let's add 2. Yeah. Okay. Yeah, we added 2. That was adding 2 is the right deal. Oh gosh. I didn't think I would get into explaining this on the live stream here, but okay, so when Ruby builds up a linked list of instruction sequences, a lot of the objects are actually Ruby objects themselves, and this this number is a Ruby object. It's actually a Ruby object, and it's a Ruby integer. So Ruby integer is the way that we know that they're integers. We use a system called tag pointers, and let's say like the number 1, Ruby's number 1 is actually going to be represented as in binary as 0BB. So it's actually going to be represented as a number 3. In like if we were to look at it in memory, it's going to be represented as a number 3. So the way that we convert to a Ruby object or convert a Ruby integer is we just shift down, like we shift down 1. And the way we convert the other way is we shift up and then we add 1 to the last bit. So the problem here is like adding 1 turned it into a wrong thing. It's not a tagged integer. So we like really, I guess what we should do is like, I don't know, int num to int num plus 1. Then like, I don't know, int to num. There's got to be a better way to do this. Like that's basically the same thing. So if we recompile this, run it, we're gonna get, like it's not gonna blow up. Yeah, it's basically the same thing. So what is going on here? It's mad. It says we got an operand size. Oh, interesting. Operand size miss. That's interesting. Why is that? Operands. Operand size. Okay, let's print out the operand size. What is this? Actually, let's just do a breakpoint here. What are we at? 3892 LDB. Actually, we'll just do make LDB. Let's see. I don't know about 4. So pointless one is asking, I don't know about 4. How many things we need to pop off the stack, but it feels a bit too generic for an instruction. Does it mean the method itself has to make sense of what is, I can't read that. What is an arg and what should be in the array? Yes, that's pointless one. That's correct. So we know during compilation, like the original instructions were like, let's print out the non-optimized version. So the non-optimized version, we know that we had a new array instruction, and we know that there's a put string, and we know that there is a pack call. So we also know that pack only accepts one parameter. So based on those facts, what we can do is rewrite this and then call into the pack method with that value. So we know that, like, we assume that pack only takes one arg, and since we assume pack is only taking one arg, then we know that the array is actually n-1. Let's see, operand size is odd. I feel like this should just be 2, but let's take a look. Let's see, b compile.c 3892 run. Okay, I don't want to figure that out, so we're just going to do n, and then we're going to do p n I obj arrow operand size. What is, oops, no, let's do, oh my gosh, 1. Yeah, that's probably not right. Just do 2, see if it works. All right. Oh, we want with optimizations. Hey, that's not bad. Nice. All right, we got this going. It should be 2. I really don't like hard coding this. Put in a little like smile there. Yeah, there we go. Don't hard code 2. Okay, I should do like fix me. All right, so we got the optimized instructions out. Like, it's working, it's out now. But if we actually try to execute this, it's gonna blow up. So let's try executing it and then see it crash and then fix it. Mini Ruby test.rb. What are the number? Generic Steel is asking, what are the numbers to the left of the instructions? So these numbers, that's a great question. These numbers here on the left of the instructions are actually the byte offsets of the, in the bytecode of the instruction itself. So the put object, this put object into fix1 starts at byte offset 0. And then set local water closet 0, it starts at byte offset 1. So what that means is this instruction, well, not byte offset, let me be accurate. Each instruction is a pointer wide. So this is at the 0th pointer, this is at the 1st pointer. So we know that put object into fix1 only consumes one pointer width inside the bytecode array. And that's what all of these are. So like we can see here, it's kind of interesting, like put string here, it's actually 2 wide, 2 pointers wide, because 11 minus 9 is 2. All right, let's run this. Mini Ruby test, boom, yes, blows up. And it's blowing up where we want it to. It says unreachable. Let's look at where, unreachable. To reach the unreachable code. Okay, let's see. We're gonna run it. Mini Ruby test.rb. Okay, blows up, and the reason it's blowing up is because in the instruction sequences, like in the actual implementation of the instructions, it's like, whoa, I don't know what array.pack is. So like we have this bug. So let's go take a look at, I'm gonna look at ins and s.def. That's where all the instructions are defined. Oh my goodness, we're running out of time here. Let's see if we can get this going. 912. All right. So you can see here, this is the implementation of all the VM instructions. So here is our op new array send. We made it into op new array send. We have some number of parameters. We have a method. And then down here, it's like, hey, for ID hash, I want you to call this function. For min, call this function. Max, call this function. And obviously, we haven't implemented pack yet, so let's do that. ID pack. And what I'm going to do is, we're just going to do Sam Bostock. GPT claims WC and set local WC0 is workspace caching in Ruby VM. It's wrong. Okay. I do remember what it is. I just think that water closet is funnier. Because I keep thinking water closet. So what it's for is wildcard. It's called wildcard. It stands for wildcard. So like, let's look at the instructions, the non-optimized instructions. So you see this set. We're gonna take a little detour here to explain this. Because I don't think there's any way we're gonna get packed. We're not gonna finish this. This is not gonna happen. We'll write the function, but it's not gonna work. So set local has two parameters. So this gives us the name, but the VM doesn't actually have the name in it. It's looking up the name later to print it for us. Has two parameters. This is 0 here and this 0 here. And this tells us how many environments up we need to go to find that local. And it also tells us an index into the array at that particular environment. So we have two different integers. So when we say like when we print out the optimized instructions, we're saying like, hey, this 0 here actually got encoded into the instruction itself. So we're saying like, hey, you go up exactly 0, and then we need you to look at the 0th index. So this WC actually stands for wildcard, and it means go ahead and check that index. But I prefer to say water closet because I think it's funny and it just sticks in my head all the time. So we're gonna do ID pack, new array pack, stack address from top. So this is Mateus is asking, are environments scopes in a linked list? They are not in a linked list. They are a giant array, but you can figure them out via. Actually, no, they are a linked list. Sorry. That was silly of me. Yes, they are a linked list. It's how many control frame pointers to pop back up and check. Okay. See it. Control frame pointer is the stack frame. How many stack frames to go back up? Let's see. So we want new array pack. Stack address from top is saying like, hey, I need you to calculate the from the current stack pointer, I need you to go up an amount, and then that's where we're going to start. So num makes sense. We do want to go up 4 because that's the start of our array, but our array is actually num minus 1 in length, right? So let's make a new function like kind of like this one. Let's see if we can at least get see if we can at least get in here. Let's see. Okay, so we're just basically going to copy this new array max thing and do our own, which is like new array pack. We're not gonna deal with monkey patches right now. Just not gonna do it. Let's find min and max. That's interesting. Min, max. Let's look at hash. That's probably easiest. Yeah, here we go. RB array hash values. Let's do this for pack. Let's see. Interesting. So pointer num is going to be our pack string. ptr sub num. I believe that's going to be our actual pack string. Let's check it. Let's see. rp str. Let's just exit here. See if we can actually get the pack string printed out. If we can get the pack string printed out, I'm gonna call it a win and end the live stream. Let's see. Okay. What did we do wrong? Compile.c 3886. Did I do something wrong? 3886. Did I mess something up? I wonder if it doesn't like that. Oh, num. Interesting. Ah. Ah ha 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 ha. Yeah, there we go. Alright, yeah. Okay, we got our new array send. Let's actually run it. Oh, T false. No. Okay, so it's clearly not that. Let's see. Let's actually break in here and check what's in this thing. So we were able to get into this. I just got the wrong value. So let's try to figure it out. Let's see. Let's do B there. Run. Let's see. Let's just do like RP, PTR. Let's see what's in this thing. There's 1, 2, 3. Ah, there's our string. Oh, interesting. What happened to 0? What is our actual code? Let's take a look at our actual code. Forgot what it is. 1, 2, 1. Let's make this 3. Let's see. Let's see. PTR 0. Oh, let's do R. Okay, actually, this is pretty illustrative. So, like, as I was saying, Ruby uses tagged integers. So our first value is 1 in Ruby here. So that's our value. But if we print it out in LLDB, we'll see that the value is actually OX3, and that's because we've shifted over 1 and then set the last bit. Okay, so if I do like RP PTR 0, we get our 1. Oh, I misspelled that. PTR 0, we'll get our 1. Let's do 2. 2 is 3, and then 3 should be our string. Hey, this is great. So what is oh geez, let's find that thing. Where is our einsns.def? I already forgot where these things are. New array.pack git. Let's check. Probably in here. Yes. Okay. So stir. What is num? Let's check out. Like, what the heck is num? P num. It's 4. Oh, okay. Okay. So we're just off by 1. Let's print out the string. Let's get -1, and then array hash values. We got to figure out this. We're gonna have to figure out a function that calls pack with the values. Let's. I think we can do this. We're so close. Mini Ruby test. There is our string. Yes, there is our string. Let's find pack. Where the heck is pack? It is apparently not in array.c. That's great. Okay, let's just find it. Git grep pack. That is in pack.c, of course. Is it in pack.c? Is that it? I guess so. All right. Pack.c. No, I do not know where this is defined. There's one other place we gotta look. Def pack. Oh boy. Okay. Huh. Interesting. Where the heck is pack defined? Boy. All right, I'm gonna quit here. I will finish up the patch and then submit it upstream and then put a link to it in the comments. Anyway, if future viewers have any questions about this, please put it in the comments. Or if there's anything you want me to talk about in the future, of course, put it in the comments. Yeah, I saw that iPack. I saw that too, but it's not it. Okay, let's go back to Keynote for a second. All right. Let's see. Next time, I am going. So my next live stream. We have time to. No, I gotta go to work. I got a day job. Look. So next time, I'm taking November off. I'm gonna be out most of November. So next time, I'm gonna do December 15th. I'll probably do TenderJIT hacking unless somebody else has something you want to see. If there's something you want to see, let me know. Also, have a good weekend, everybody. Thank you so much for coming, and of course, don't forget to like and subscribe, YouTubers. Thank you. Bye.